Hello there. In this lesson we're going to learn about construction 14. Now construction 14 is a special case of a triangle ASA, and we know that ASA stands for angle, side, angle. So we've been told what 2 out of the 3 angles are, and we have also one side length measurement. But the special case is because one of the angles that we've been given is 90 degrees. So it's another right angled triangle construction. This type of construction comes in 2 formats, depending on the side measurement that we've been given. So as you recall, we've only been told one side length. Now that means that the side length could be the hypotenuse, which we learnt in the last construction video, meant the side that doesn't touch the right angle, it's opposite the right angle, or it might not be the hypotenuse, it could be one of the other sides. So we have 2 possible scenarios. If it is not the hypotenuse, then the triangle might look something like this. So we've been given one side length and we've got 2 angles, one of which is 90 degrees and the other is 30. And that would be fairly straightforward to construct because the 90 degree will sit on the end of one of our endpoints of our baseline, the side that we've been given, and then we can use our protractor again then for the second angle. So when it's not the hypotenuse that's been given, it's actually quite straightforward. It's constructed the same way as ASA that we learned in our previous construction video. But when we have been given the hypotenuse as the only side length, then that means it looks something like this. And this is where we have a problem. So we were only given this one angle and the 90 degrees. We were given this side length, but how do we know where to create this angle up here? The constructions of triangles when we have the angles are relatively easy, providing we have the 2 angles that sit at the 2 endpoints of our baseline. So in this case, this is when we have to do one extra step. And rather than us trying to figure out our 90 degrees up in the air somewhere here, we're actually going to remember the theorem that all 3 angles in a triangle add to 180 degrees. To find out what this third missing angle is, and we're actually going to end up constructing the 30 degrees, so the one smaller acute angle that we're given in the question, and then this missing angle by adding these 2 up together, so 30 plus 90 makes 120, and that means if we take 120 from 180, then we're left with 60 degrees. So we would construct 60 degrees here, and that's going to help us. So sometimes we might have to do an extra calculation to work out our third missing angle in order to construct a right angled triangle where we're given the hypotenuse. You can see it's the opposite, it's not touching the right angle, and one other angle. So these are the extra calculations that I would have written down. For us to be able to construct this triangle, we need the base of the triangle and then the 2 angles at either end. So we can place our protractor on this end and draw 30 up, and the protractor on this end, and we've calculated that the missing angle ACB, so the angle that sits here at C, is the total number of degrees for a triangle, 180, minus the 2 angles that we've already been given. The right angle being 90 and this 30 that we're told in the question. So 180 take away 30 and 90 means that that missing angle is 60. So I'm actually going to construct the triangle using these 2, but remembering that I must label my 90 degree once I've finished. So let's have a look at one being done from scratch. So the question is asking to construct a triangle ABC. So we have the 3 vertices, points A, B and C. And the side length A to B measures, so there's a distance between them of 7 centimetres. And we've got 2 angle measurements. So the measurement of the angle ABC. So It's 90 degrees, a right angle triangle. The 90 degrees sits at point B, and we've got one other angle for the point C. Angle ACB, so it sits at C, is 60 degrees. For us to get started, like always with the constructions, we'll draw a little sketch so we know what to expect. So if we start off by drawing our one and only side length, remember that this is just squiggly because it's demonstrating it's just a rough sketch, but I'd still like to see it nice and neat in your copies. And we know that the angle at B is 90 degrees, so we're going to have the 90 degree angle up here. Now, we haven't been given the angle here. We've only been given the angle from C. So this is going to help us understand we need to add a little bit of calculations in to work out what the angle is here. If we know the two angles at both endpoints of the one side length that we've been given, so the one that we're having as the base of our triangle, then we can quite easily construct this triangle. So we know it's going to look something like this. 90 degrees is there, 60 degrees is here, but it's really going to help us to work out what this third missing angle is. So we can do that by remembering that all three make 180. And if we take the two that we already have, the 60 and the 90, away from it, then it tells us that our last angle, the angle that sits at A, so the angle B to A to C, so it's this angle here, is 30 degrees. So we're going to use that then to help us to construct this triangle. So that's the only difference between this construction and the one that we previously learned about ASA, is that we need to have the two angles at both ends of our one side that we've been given to construct properly. So we might have to do a little bit of a calculation to find our third missing angle before we get started. So it's time to construct the actual triangle. We know that we need a sharp pencil and a ruler, and we're going to start off with our baseline, just like our sketch showed, from the point A to B, which measures 7 centimeters, and we need to mark on those measurements in a pen. And we know that we have two angles then, which we're going to now construct using our protractor. We can start with the right angle at B, so we mark up our center mark of the protractor with the point B, place it exactly on the little cross, making sure that the baseline of the triangle and the baseline of the protractor are exactly on top of each other. And then we can see which zero does the line of our triangle go through. It's not going through the zero on the protractor over here, it's going through this one. So we're going to be using that scale of numbers, the outer scale, until we get to 90, which is just there. I'm going to put a little dot, move our protractor away, and we're going to connect now our point B with that dot, making sure that the pencil is exactly in line, not slightly to the side because we've had the straight edge too close to it. And we're going to continue to make sure that that line goes up quite nice and high. That's your workings, it's your construction marks, and they're all worth marks in your exam. So there's one angle, our 90 degrees, and we'll make sure that we label it with our, they've written 90 degrees here, but a little square box would be better. So now we're going to then do the same thing on our other end point, and we know that we've calculated that to be 30 degrees. It wasn't what was given in the question, but we have calculated it by taking away the other two angles from 180. So again, line up our center mark of the protractor with point A. Which zero does the baseline go through? It goes through this zero. See, if you look at this zero, there's no triangle line underneath it. So we're not going to use that scale this time. We're using this one. And we want 30 degrees. There's the number 30. Let's place a little dot exactly outside of it. And the last thing to do then is to extend from the point A through that very accurately and neatly. And we keep going until it intersects with that previous construction line. Now, of course, if your lines don't cross, it simply means you haven't drawn them long enough. So just extend them a little bit more. So that means we have now found our point C, our third vertex. And we need to make sure that we label all the information that's been given to us in the question. So we have A, B, and C. We have the 90-degree angle. We have the 60 degrees, and we have the 7 centimeters. And of course, we calculated ourselves the third angle to help us to perform this construction accurately. So I will demonstrate doing one myself. So this time the question says to construct a triangle, and we've been told that the side length A to B is 6 centimeters, and we've got 2 angle measurements, and notice that one is 90 degrees. And this time the second one that has been given in the question is 30 degrees. So we'll start off with our sketch to see what we have got. So there's my sketch complete. So we have the baseline, the only side length we've been given, so we have to have that at the bottom. And we know that when we have a right angle triangle, that we need to have both of the vertices. If we've only got one side length, we need to have the angles for both of the endpoints of that side length. And as the sketch shows me, it is this one up here that we've been given, as well as the 90 degrees. We haven't been given this one in the question. So the first part of my answer then is going to be calculating what this missing angle is, because in order for us to accurately construct this triangle, we need the 2 angles at the end of both of this side length. So I've calculated my angle BAC, my missing angle, so that I have both of these 2 angle measurements. So I construct it by remembering that there are a total of 180 degrees for all 3 angles. So if I take the 2 that we've been given in the question, the 90 and the 30, away from that 180, it tells us that what's left has to go here, and that's 60 degrees. 180 take away 90 is 90, take away another 30 makes 60. So I've added that to my sketch, so that will help me now when I construct to know that I will start with my baseline, and then I can create my 90-degree construction line and then my 60-degree construction line. And of course, we'll be able to check our result afterwards by measuring this angle on our construction, and it should be exactly 30 degrees. So I've started off by drawing my base of my triangle, and you can see there that I've got a nice sharp pencil, and that means it's very accurate and easy for me to get exactly 6 centimeters for that line segment, the distance from A to B. So the next thing that we'll do is we will create the 90 degree. Now remember that we are going to, if we're starting with the bottom, the rest of the triangle's above it, so you're making sure you've left space for your construction to go further up. So we're going to use our protractor to perform our 90 degrees. So we're going to place it exactly on the point that the 90 degrees sits on, which we know is B, the middle letter here for this angle notation. Making sure it's exactly then the point underneath the cross, our center mark, and that the baseline of our protractor is exactly on top of the baseline of our triangle. So once we've done that and making sure that we don't slip, we are going to figure out which scale to use, and that's the scale where our line travels through the 0. So you can see there's no line of a triangle under here. There's the 0, there's nothing there, so I'm not going to use the numbers counting up from 0 this way, the inner scale. We're going to use them from this one. There's the line of our triangle passing through the 0 here on the outer scale. So we go up until we meet 90, and we know 90 is right at the top, it's perpendicular. We're going to leave it a very accurate, you can see that because my pencil is so sharp, that I can really accurately put that marker, and it's definitely correct. It's like an extension of that line that shows it's 90 degrees. So then I can take it away, and I'm going to connect now my point B up with that little marker. Now I'm not going to line up my ruler exactly on top of it because that's going to push the pencil edge slightly to the left. So I need to line up my pencil with the point and then push my straight edge against it. And that means I know it's definitely going to run through that point and to our vertex B. Now, of course, there is another way of easily drawing a right angle, a 90 degree, and that's using our other tool in our math set, and that's our set square. We know that the two edges here, they're exactly perfectly perpendicular, 90 degrees, so we could use that instead of our protractor. And remember that we must have notation, symbol notation, so either the box or this little pair of perpendicular lines to show it's 90 degrees. Okay, so now we've drawn the one side, we need to draw on our second angle. So we're going to create our 60 degrees that we calculated ourselves at the point A, and 60 degrees means we are going to have to use our protractor this time. So just like before, line up our center mark and our baseline of our protractor perfectly, making sure then that we find the scale that starts from 0 that our line of our triangle goes through. So look at the 0, there's no line underneath it. So I'm not going to use those outside numbers, I'm using these inside ones. And we need 60, there's the number 60. So again, being careful not to move my protractor. Now I'm holding a camera, so but you will have one hand firmly placed on your protractor and the other one then can you for the pencil, so you will have no reason to accidentally slip. And now all that's left to do then is to again accurately making sure that it goes through that point and connects with my point A, draw my line up. Now I can see that I'm actually going to run out of slightly a space here and I didn't draw my construction line quite big enough, but that's fine. All I'll do is I will extend it further so that they do actually intersect. So there we have it. I have actually demonstrated to you the importance of starting your triangle quite low down on your space. I started it up here and I didn't have enough room without going into my title. So, you know, learn from my mistakes as well as your own. And we have one more thing to check. Have we got all 3 points labeled? Yes. Have we got all 3 pieces of information labeled? 1, 2. We need our third. We need the 30 degrees that we were given in the question up here. Now we don't actually have to label the 60 degrees here because that wasn't part of the question. We just used it to help us get the 3 pieces onto our diagram. And we already have our sketch with the label of 60 degrees, and we have clearly shown our calculations of how we got that 60 degrees. Now, the only thing left to do would be to actually check, all we know is to verify in maths that we were correct, and I can do that by lining up my protractor with my point C on the center mark and figuring out, is it 30 degrees? Excellent. There we have it. So I'm going to ask you please to construct this exact example in your notes copy, including the steps which I have just written down there. So we know that once we have that missing angle calculated, that the rest of the construction is the same as construction 12, which of course is a triangle ASA. So if you can please pause the video, you can either look back over it and keep pausing with every step and stage and make sure that you have this in your notes copy. Just demonstrating the same construction again. We start with the baseline. We make sure that we have the 2 angles that are on the 2 endpoints of that baseline. So the angle at B in this case, which was given as the right angle, and the angle at A. If we haven't been given that, then we have calculated it ourselves. Where they cross at the top then is our third and final vertex, and we must make sure that we label any information that was given in the question. And before you go, one last thing. What does the triangle say to the circle when they have an argument? You're pointless. Thanks for listening. See you in the next class.